Imagine this. It's September 12th, 2025, and the night sky over observatories worldwide lights up with urgent pings from telescopes. Astronomers, bleary-eyed from endless data streams, spot something impossible, a blazing visitor from the depths of space, its tail unfurling like a cosmic ribbon 5 times wider than the full moon. Within hours, confirmations flood in. This isn't just any comet, it's C/2025 R2, quickly nicknamed Swan for the graceful arc of its path, captured in the solar wind anisotropies instrument aboard NASA's SOHO spacecraft. But here's the twist that sends chills down spines. Almost simultaneously, from the opposite side of the sky, another anomaly streaks in, 3I/ATLAS, the third confirmed interstellar object ever detected in our solar system. Two rare cosmic wanderers, both hurtling toward the sun in a narrow 10-day window, their paths crossing like threads in a vast tapestry. Coincidence? In the grand chaos of the universe, maybe. But for space enthusiasts like us, it feels like the stars are whispering secrets. Why now? Why together? And what could they tell us about worlds beyond our own? Today we're diving deep into these interstellar intruders, their discoveries, their quirks, and the mind-bending questions they raise about space exploration in 2025. Stick around because by the end, you might just rethink everything you thought you knew about our place in the cosmos. If you're new here, hit that subscribe button and ring the bell. We've got more space mysteries coming your way. Let's rewind a bit and set the stage. Comets have fascinated humanity since ancient times. Those fuzzy harbingers of change streaking across the sky, inspiring both awe and omens. But Swan and 3I/ATLAS, they're not your garden variety solar system locals. Interstellar objects like these are refugees from other star systems, ejected billions of years ago by gravitational tussles among planets or passing stars, now slingshotting through our neighborhood at speeds that make our fastest rockets look like snails. Think about it. While most comets orbit the sun in predictable ellipses, these guys follow hyperbolic paths, open curves that mean one-way tickets in and out, no return engagement. The first we spotted was Oumuamua in 2017, that enigmatic cigar-shaped rock tumbling silently, sparking debates from natural origins to wild theories of alien solar sails. Then came 2I/Borisov in 2019, a full-fledged comet with a gaseous tail, proving these visitors could be icy worlds just like ours. Fast forward to 2025, and bam, 3I/ATLAS bursts onto the scene, discovered by the Asteroid Terrestrial Impact Last Alert System in Chile back in July. Initially cataloged as C/2025 N1, its hyperbolic orbit screamed outsider, clocking inbound speeds over 30 kilometers per second. And Swan, spotted just weeks ago on September 11th by amateur astronomer Vladimir Bazugli, sifting through SOHO images, it's a long-period comet from the Oort cloud fringes, but its trajectory hints at interstellar routes too, with an orbital period stretching tens of thousands of years. What binds them isn't just rarity, only 3 interstellar objects in human history, but their synchronized drama. As of early October, both are barreling toward perihelion, their solar closest approach, around mid-month. For 3I/ATLAS, that's October 15th, skimming just 1.4 astronomical units from the sun. Swan follows suit 3 days later, at 0.8 astronomical units. Picture 2 ships docking at the same interstellar port, right as Earth's view gets fogged by solar glare. It's the kind of alignment that makes astronomers pinch themselves. Is the universe staging a show just for us? Now let's zoom in on Swan, this behemoth that's already stealing the spotlight. Discovered glowing green against the solar wind's backdrop, its coma, that hazy envelope of gas and dust, spans tens of thousands of kilometers, with a tail so elongated it rivals the Great Comet of 1744 in sheer spectacle. Early observations from ground-based scopes in the southern hemisphere peg its nucleus at maybe 10 to 20 kilometers across, a dirty snowball laced with frozen volatiles. But Swan's not content with looks alone. Its brightness curve is surging, potentially hitting magnitude 5 by late October. Naked eye visible under dark skies if you're in the right spot. Look west after sunset, low on the horizon. Spectrographic data from the European Southern Observatory reveals the usual suspects. Water ice, carbon dioxide, and silicates, but with intriguing spikes in sodium and organic compounds, those carbon-rich molecules that whisper of life's building blocks. Fun fact, these polycyclic aromatic hydrocarbons, or PAHs, are everywhere in space, from interstellar dust to your morning coffee aroma. Yes, they give char a scent. But in Swan, they're concentrated, almost pristine, fueling chatter about how Oort cloud objects preserve chemistry from the solar system's dawn, 4.6 billion years ago. As it nears the sun, solar heating will vaporize its ices, birthing jets that might spin the nucleus like a cosmic top. We've seen this with Rosetta's Philae landing on 67P, where outgassing twisted the comet's rotation by 10 degrees per day. Swan's no different, but on steroids. Imagine the pressure. Billions of tons of ice sublimating into plasma, pushing the tail into that iconic curve. And get this, amateur imagers worldwide are already capturing it, from Chile's Atacama to Australia's outback, turning backyards into observatories. It's a reminder that space exploration isn't just NASA's domain. It's ours, collective, democratized by apps like Stellarium and scopes under $500. Yet as thrilling as Swan's ballet is, its partner in this cosmic waltz adds layers of intrigue we'll unpack next. Shifting gears to 3I/ATLAS, the true interstellar wildcard. Unlike Swan, confirmed from another star's nursery, likely ejected from a system 10 to 20 light-years away, Atlas embodies the raw unpredictability of the void. Discovered at 420 million miles out, it's smaller, nucleus estimated at 1 to 2 kilometers via Hubble's sharp eye in August. But don't let size fool you. Its hyperbolic eccentricity of 6 means it's hauling at escape velocity, unbound by our sun's gravity. As it zipped past Mars on October 2nd, NASA's fleet, Perseverance, Curiosity, and the Mars Reconnaissance Orbiter snapped data like paparazzi, revealing a vivid emerald glow from diatomic carbon in its tail, shifting hues as it activates. Spectroscopists note cyanogen and C2 molecules, classic comet fare, but the bursts? Ah, those acceleration spikes that had everyone buzzing. Over weeks, Atlas exhibited 3 sharp velocity jumps, each demanding gigawatt-level energy, equivalent to a nuclear plant's output. Natural? Absolutely, per NASA. Uneven outgassing from uneven heating, like a garden hose kinking and unkinking. No thrusters needed, just physics doing its thing. Yet these maneuvers echo Oumuamua's non-gravitational drift, which Harvard's Avi Loeb famously theorized could hint at artificial light sails, though most peers chalk it up to ice vents. For Atlas, ESA's Rosetta team draws parallels, noting similar jets on 67P/Churyumov-Gerasimenko. By October 10th, as it nears Jupiter's orbit, Juno might catch a glimpse, probing its dust for clues on extrasolar chemistry. What's wild? Atlas's tail isn't static. It morphs, elongating to millions of kilometers, ion tail pointing anti-sunward under solar wind's push. Ground trackers from Hawaii's Atlas Array to Chile's VLT are feasting on data, measuring coma expansion at 100 meters per second. And the color shifts, red to green? That's excitation of gases by UV light, a fireworks display of electrons leaping energy levels. For beginners, think of it like neon signs flickering to life. For experts, it's a lab for modeling interstellar delivery of organics to young planets. But pair this with Swan's steadier glow, and you see contrast. One agile scout, the other majestic cruiser, both priming for their solar showdown. Here's where it gets synchronistically spooky, the orbital choreography of these two. Plot their paths on a star map, and your jaw drops. Swan dives in from Aquarius, Atlas from Sagittarius, origins quadrants apart across the celestial sphere. Yet despite wildly divergent vectors, they thread the same solar corridor. Inner system entry at roughly 1 astronomical unit. Perihelia spaced by mere days. October 15th and 18th. Statistically, astronomers crunch the numbers using Monte Carlo simulations, odds slimmer than winning the lottery twice. Random long-period comets pepper arrivals over millennia. Interstellar ones, rarer still, like cosmic needle in haystacks. This alignment, it screams selection bias from our improving tech. Vera Rubin Observatory Online soon will spot dozens yearly, but also evokes deeper wonder. During their closest solar hug, from October 8th to 18th, the sun's glare erects a natural blackout, veiling direct views from Earth-based scopes. SOHO and Stereo A, our solar sentinels, step in, but even they strain against corona noise. It's like two guests arriving at a party just as the host dims the lights, frustrating yet poetic. Orbital mechanics explain the how. Kepler's laws dictating elliptical tugs, perturbed by Jupiter's gravity for fine-tuning. But the why together invites storytelling. Recall Halley's Comet, threading cultures from Chinese annals to Mark Twain's birth-death marker. What if Swan and Atlas etch a modern myth? Hypothetically, if we launched a probe, say a scaled-up DART, toward ATLAS, travel time clocks 50 years at current speeds. Instead, we observe passively, piecing trajectories via JPL's horizons ephemeris. This corridor convergence isn't engineered. Physics doesn't plot conspiracies, but it spotlights our vulnerability. 99% of space remains unseen, teeming with unseen travelers. As they align, questions bubble. Could ATLAS seed Earth-like worlds en route? Does Swan's organics mirror prebiotic soups? It's progressive revelation, from basic hyperbolic math to advanced astrobiology, building our cosmic literacy one alignment at a time. Diving deeper into the data deluge, energy signatures from these duo are rewriting textbooks. For Atlas, those thrust-like bursts, ground truth, sublimation inequality. Ice pockets vaporize unevenly, expelling gas at 1 to 10 meters per second, nudging the nucleus 0.1 to 1 millimeter per second squared. Peanuts compared to artificial propulsion, but measurable via astrometry from Gaia satellite. Energy. Solar input heats the surface to 200 Kelvin, liberating 10 to the ninth joules per burst, akin to a small dam's output, not nukes. Earlier hype scaled wrong. Swan's steadier hum? Its luminosity implies albedo of 0.05, dark as charcoal, absorbing sunbeams to fuel a tail pulsing with, wait, not rhythms, but solar wind interactions. UV imaging from Swift telescope shows sodium layers fluorescing, creating that halo effect. No metallic sheen, spectra scream carbon and silicates, not nickel alloys. Yet Webb's infrared gaze, locked since September 20th, unveils PAHS at 10% abundance, structured like graphene sheets, perfect for radiation shielding in theory, but naturally forged in stellar outflows. Compare. Earth's grid peaks at 20,000 gigawatts. Swan's output is reflected input, not generated, peaking at 10 to the 12th watts absorbed. Vast but passive. Fun analogy, like a black car baking in the sun versus a white one staying cool. These metrics ground us, but spark what-ifs. Loeb posits in his August Medium piece that if non-grav drifts exceed models by 10%, artificial origins merit a glance, backed by Oumuamua's 0.1% anomaly. For Atlas, drifts fit ice models within error bars, per Nature Astronomy's September preprint. Swan? Too fresh for full sims, but ESA models predict standard decay. Still, the scale, Swan's 22,000-year cycle, overlaps Ice Age ends, tempting links to Göbekli Tepe's sky carvings. Coincidence or cosmic calendar? Science says former, storytellers, the latter. As data flows from ISRO's AstroSat to amateur CCDS, we balance rigor with romance, ensuring space exploration stays factual yet fueled by curiosity. But no cosmic tale skips the human drama, the hush from the heights. As perihelion looms, NASA, ESA, and peers throttle public feeds, citing conjunction downtime. Standard protocol to shield electronics from solar flares. FOIA docs, Per Planetary Society leaks, show redacted radar pings, reassign staff. Not conspiracy, safety first. Coronagraphs overload at zero point 0.5 astronomical units, yet it amplifies grassroots fire. Bill Gray's Project Pluto networks 50 amateur scopes, piping ephemerides in real time. Spain's Abero Collective crowdsources spectra, spotting SWAN's CN band at 388 nanometers. This democratizes discovery, echoing Galileo's backyard gaze. Why the veil? Solar interference blinds opticals, but radio ALMAs at 0.5 millimeter waves pierces, hinting at dust grain sizes. Atlases at 1 micron-sized, scattering light blue ward. No signals, no jams, just noise. Independent trackers fill gaps, plotting tails via itelescope.net. It's empowering. You, with a $200 Celestron, contribute to Arshiv preprints. This blackout bursts community, turning silence into symphony. And as Atlas grazes Jupiter, October 12th, Juno's Giram might sniff volatiles, comparing to Europa's plumes, bridging interstellar to icy moons. Swan's post-perihelion fade. By November, magnitude 8, binocs only. But the legacy? Data archives for AI pattern hunting per SpaceX's Starship Scouts. Institutions quiet? We roar louder, proving space belongs to all. Wrapping our heads around implications, let's project forward. These visitors aren't just pretty lights, they're time capsules. Atlas from afar carries extrasolar isotopes, deuterium ratios differing 20% from solar norms per preliminary VLT data, clues to alien ocean worlds. Swan? Its organics, if panspermia vectors, suggest life-hop stars like hitchhikers. Theoretically, Loeb's 1% artificial odds rise with anomalies, but evidence tilts natural 99.9%. Future: Rubin Observatory's 2026 LSST will net 10 interstellar hits yearly, Vera C. Rubin spotting one per month. Missions: ESA's Comet interceptor, launching 2029, chases one dynamically. SpaceX's 2030 Mars fleet might detour, but interstellar chases demand nuclear propulsion. NASA's Draco test in 2027 key. Ethically, inclusivity shines. Diverse teams, Bazugli Russian, Atlas Chilean, globalize astronomy. Gender-neutral quests unite us, from indigenous star lore to quantum models. Comparisons? Earth versus these, our water 0.02% mass, comets 50%, oceans and ice. Timeless. As climates shift, Swan's cycle reminds resilience. Hypothetical: if Atlas seeded Earth 4 billion years ago, we'd owe our DNA to drifters. Grounded yet grand, these events propel us toward stars, one data point at a time. So there you have it, the saga of Swan and 3I/ATLAS, two cosmic couriers crashing our solar party in 2025, challenging our understanding of space exploration from the mundane to the marvelous. We've journeyed from backyard discoveries to orbital ballets, energy puzzles to global collaborations, all while grounding wild wonders in solid science. Key takeaways? Interstellar objects aren't myths. They're measurable messengers, urging better scopes and bolder questions. But here's the thought provoker. If the galaxy flings these at us every few years, what else lurks unseen? Are we alone in noticing or part of a larger web? Ponder that under tonight's stars. Grab binoculars. Hunt Swan Low West. What do you think? Natural nomads or something more? Drop your theories in comments. Best one gets a shout out next vid. If this ignited your inner astronomer, smash like, subscribe for Mars updates and black hole breakdowns, and check our playlist on recent space discoveries. Thanks for exploring with me. Until next time, keep looking up. The universe is calling.